that Benjamin has a question. Just give me 1 second to finish getting organized here. Okay. Let's see. So I think the first thing I'm just going to start by doing is just reminding you where most of the review material is, and also remind you or show you something about that I posted on Blackboard here. So I'm going to share my screen. I am now sharing my screen, and so you should be looking at my Blackboard page. When you go into linear algebra and you go to our course documents, it brings up this page, and you can see the thing I put at the top says test instructions and exercise for Monday 4/13. And so when you open up the instructions document, it'll just give you a rundown. It's nothing I haven't said before, but just it answers like frequent questions. It sort of gives the general idea about how the test is going to work, and we can talk about that more a little bit later. And then this is the thing that we're actually going to do at the end of this class. This is kind of what the test is going to look like, and so I'll just sort of run through that after we've done some review. The other thing is the topics, which is I just took a look and downloaded to see who has done this, and not everyone has even downloaded the topics yet, so you should just be aware that the topics are right here, test topics, right? And then there's some review material in this review packet, but this isn't like a comprehensive list. This is just a review thing that like was given to me by another linear algebra professor that was created by other students. And so it's nice, but it's not like the end all be all. I think another good thing to study if you want like practice problems would be the written homework. So all the written homework and the solutions are in the written homework, practice problems and solutions in here. All right, all the solutions are down here at the bottom. And so those are really nice to just practice. Obviously, the homework, the online homework can be used as well. As far as the specific topics, maybe I should just mention what the topics are first. Let's see here. What do I do with the topics? The topics are all of Chapter 1, and then also 2.1 and 2.2. And so that's exactly what it says throughout this document. It basically goes through each section and lists the topics in each section, and then you can see it stops at 2.2. And I've written the test for about a normal class period, so about 75 minutes, but you're welcome to take as much time as you need. If you feel like you need more than 75 minutes and you have something that butts up against our time period, please let me know as soon as possible so we can figure out how to make that work. Okay. Can I answer sort of, well, let's actually just, again, let's just do some review. And then we can answer, I'll be happy to answer as many sort of general questions people have about the format and things like that. But let's just do some review first. So let me answer Jason's question. So Jason asks, what sections of the web work homework will be on the test? And I'll just mention again, the sections that are being covered on the test are all of Chapter 1, and then 2.1 and 2.2. And so from web work, that would just be 2.1 and 2.2. We did all of Chapter 1 via written homework. Let's see, Pigeon's saying I made a mistake on the test topics. Let me double check that.
I think, first of all, can you hear me?
Yep, I can.
I'm distinctly looking through it and comparing it with the notes. When you go from, like, with a transformation from the domain to the codomain, it's N to M, right?
Correct.
On the topics, you have it M to N.
Let's see here. Oh, so those are just generic letters, right? They're not actually fixed at all. I agree. I should have maybe been consistent and kept it the same way.
So I thought that N kind of implied the like number of columns, while M implied the number of rows, which made sense. You have an N to M because in the end, the vector is going to be the length of the number of rows.
Sure. No, that's true. And if you look at, so I'm putting the page in the notes where it says what you're referring to here. And what's important is that it's just saying whatever is the first dimension is the number of rows, and then this number in the second dimension is the number of columns. And so whether it's an M or an N is kind of irrelevant. It's whatever number ends up being there when you plug something in, and will follow what you said, rows and columns. And so try not to get too hung up on, I mean, you see what I'm saying? It's just a letter, and I agree that, you know, the book, I guess, used N and M in this picture, and for whatever reason, when I wrote up the test topics, I used M and N. But the point is, when you go from one space into another space, the first one is going to tell you, it tells you the number of columns. I think I messed it up when I said that a second ago. The first number tells you columns, and the second number will tell you rows. Is that what you were asking about in your question there? So you had said...
No, the 1.91 was more just sort of, remember when we were trying to find the standard matrix, given either like a description geometrically of what it was supposed to do to just an identity matrix square?
Yes.
Yeah, that if you were to ask me to try to figure out one of those problems, I would be completely lost. I don't know if there was a very specific like method, or if we were just supposed to like intuit it, or...
So this is the method. So let me first start by sort of clarifying for everyone that we're talking about linear transformations, and what this page in particular is telling us, and this box right here is telling us, is every linear transformation can be written as a matrix times the vector. And so Finton's sort of asking about how do you find that matrix? And this is the top of 1.9. You can see, like it says right here, the matrix that you want, the columns are obtained by applying the transformation to the columns of the identity matrix. So the E sub i's, right? That's what it says right here. The E sub i's are the columns of the identity matrix. And so when we were doing those, finding the transformations on the following pages, that's what we were doing. And so let me run through a couple examples. So like this first sort of simple one we did, we said, okay, well, we're in R3, and so here are the columns of the identity matrix in R3, and then we applied this transformation to each one of those columns. And when we applied the transformation, which in this case was just multiplying the thing by 1/5, right, it just became these columns. And so these were the columns of our transformation matrix in the long run, because this was like the transformation applied to the first one, the second one, and the third one. And when I say one, I mean the columns of the identity matrix. And so we did the same thing on the next page. It was just we had a physical representation to go along with it. So let me just pause right there and see if there are questions about that general process before we look at the question that Finton's specifically asking about. So this is what we want to do then. We want to apply any given transformation to the identity matrix columns. And so like on the next page, that's what we were doing. So on the first one, maybe let me just, maybe I can just redo this first one. It's kind of hard to point at it with all this stuff written there. So let me just rewrite that one down and show you what I mean. So this is page 47 in the notes. And this is the picture that's on that page. It says, we start with one like this. This is the original. And then it flips down and becomes this new one. Right, this is the transformation. And so what we want is we want the matrix A. And we know that A is going to be the transformation applied to the two E's. We know there's two of them because this particular transformation is from R2 to R2, right? Like it's a two-dimensional thing, and it stays two-dimensional after we do the transformation. And so E1 and E2, right? E1 is the vector 1, 0, and E2 is the vector 0, 1. And so if we're looking at the picture here, those two graphs, this is like the x1, x2 axis, right? And so 1, 0 would be right here. Like this is the E1 vector. And then E2 is 0, 1. And so that's this one right here. And so what happens to this vector when you apply the transformation is that it flips upside down and becomes this vector. So this vector down here is T of E2. This left-hand side of the graph here. Right? And then E1 stayed the same. Right? When you flip this down, this bottom piece stays where it was. And so E1 actually equals T of E1. That actually doesn't change. And so in this case, it stayed 1, 0. In this case, it became 0, negative 1. And so in other words, T of E1 stayed the same. T of E2 flipped upside down, so it became this. And so those ended up being the two columns in the matrix. Right? And so our final answer, if you look at the notes, was this. Right, which is T of E1, T of E2. So we are applying, we're doing just what you had said, Benton. We're applying the transformation to the identity matrix, the columns of the identity matrix. They're just part of a graph now that we can actually identify. Let me know if that clarifies things.
So you just kind of find 2 points and find 2 points that are on the identity matrix. So either like, on the y-axis of that cube, like the top left or the bottom right of it, and then find where they would be when you do the transformation and plug those in for A.
Yeah, so first of all, it's not any 2 points. It's specifically E1 and E2. It's the columns of the identity matrix.
Yeah, okay. Well, yeah, but I was just trying to describe it geometrically.
Yes. Now, this is not the way I ask questions on the test. I try to do this in the homework to give you, again, a visual kind of thing to go along with it. Questions on a test often look like this instead, like T of X is defined by this. Let me start over. I'd say you have some transformation, like let's say it goes from R4 to R2, and then it's defined in this way. So if I ask something like this, I'm saying we take vectors in R4 and they get sent to R2. And so in other words, this vector right here is 1 by 4, or 4 by 1, I should say. Right? So it's a x1, x2, x3, x4. But then when you apply the transformation, it becomes a 2 by 1. So that's the R4 to R2 thing. And then this is telling us how to build the vectors. It says whenever you apply the transformation to a vector, you multiply the first and the third entry to give you the first entry in the transformation, and then you multiply the second and the fourth to give you the second entry. And so then what we want to do is we want to do A equals T of E1, T of E2, T of E3, T of E4. And each time we do one of these, this is telling us how to do it. Right, so for example, T of E1 would be like this. And this says multiply the first and the third, and then the second and the fourth. So this is going to be this is going to be really stupid because they're all going to be 0. I just made this one up on the spot. So maybe let's add them instead. I'm going to put a plus in between so that we get a non-zero thing. So now we're going to add the first and the third and the second and the fourth. So this would be 1 plus 0, 0 plus 0. Oops. Sorry, I didn't mean to put that T here. All right, we're going to apply the transformation here. Here we have applied it. And so this would be 1, 0. And so this is going to be the first column. Right? I'm not going to do this whole thing, but just to be clear, the second one would be like this. And so now there's a 1 in the second spot. And so when we do that one, it's going to be 0 plus 0, 1 plus 0. And so this is going to be the second column. Right? And you would do it 2 more times. And so it's in other words, I try to make it a little more straightforward, not have you look at like a picture, but tell you how it's defined and then see that you know how to do, like, apply it, basically. If that makes sense.
Yeah, I think that makes a little bit more sense.
That would be a question for finding the standard matrix for the transformation, right?
Yes.
Okay.
So this would be a type of question on the test for finding the standard matrix A for a linear transformation. So 1.9. I believe there was one in the written homework that was kind of like that. So there's a practice one there. Maybe there's one in one of the quizzes I posted too. I forgot to mention that too. I posted all like the quizzes we may or may not have had as well. And so there's definitely like practice problems out there to practice from for sure.
There was that's the thing. The only reason I was especially confused with this one is just I don't think we had a quiz. There was even an undone quiz. Actually, there might have been. Was there an undone quiz on 1.9?
I
usually don't
any.
get to that one because it's like right before the test usually. And so I usually don't have 1.9 on a quiz. But if I look at the homework solutions really quick here, I think there is one like this one in that homework section.
Do you think you could, like, for some of these questions, maybe in course documents, just post a couple, like maybe tonight, like some example questions of this, maybe like 1 or 2? You think you could like post like 1 or 2 questions like this in course documents, just like blank and undone?
You mean specifically for finding the matrix A?
Yeah.
Sure. I'm just looking at the homework. There's not really a great question in the homework, I guess.
I remember some things that were similar on the homework, but I remember specifically some of the ones on the homework said to find. It basically gave you. I actually forget what I did on the homework. There was something on the homework that kind of looked like this.
So, right. So the other way to approach a problem like this, which is it looks like the solutions I posted, this is how they were done, is you could say some matrix times x1, x2, x3, x4 has to equal x1 plus x3, x2 plus x4. And you know this one has to be a 4 by 2, or a 2 by 4, I mean. And so then that means, well, we need a 1 here, a 0 here, a 1 here, and a 0 here. So then when you multiply those together, you end up adding the 1 and the 3. Right? And then you would do a 0, 1, 0, 1, so that when you do that multiplication, you end up adding the 2 and the 4. And so you can see you end up getting the same thing, right? There's the first column, second column. Sorry, this should be 0, 1. Obviously, I added that wrong. But you can see we get the first 2 columns by doing it that way. So this is, if you look at, so to answer your question, there's 2 examples in the written 1.9 homework that look just like this one. It's number 19, 25, 17, 19, 25, 15, 17. So like all these ones, 15, 17, 19 in that section are all like this.
This makes a lot more sense now. Because I remember those questions on the homework being I remember understanding those questions. So I think put in that format, it makes a lot more sense. So thank you. Yeah,
I try to avoid like this explanation. There's nothing wrong with this in this problem, but this only works when you're dealing with things in Rn. And specifically like multiplying a matrix times a vector, which I know is primarily what we're doing. But the thing is, this is just, I guess it's just a little more general. I guess these E's are technically in Rn too. This is just the more general approach to the problem, which is why I try to stick to that, I think is my explanation. But anyway, yeah, so take a look at those three at least. If you want to look at them separately to double check your reasoning, we can do that, but the answers are also posted. Are there other things folks want to look at? You know, I'm not sure if maybe people haven't started studying yet. That's slightly concerning. When I like see who's downloaded the test topics, it's not everyone, and so I'm assuming that means maybe people haven't started studying. Which, you know, you guys are adults and you can make that decision. But is there something else I can do right now? I was really hoping to spend like a bunch of time reviewing, but if you don't have anything to talk about, that's okay.
I suppose one thing that I'm a little confused about is the exact concrete definition of a pivot, because we've of course used pivots a lot to like actually solve problems, but like back when looking at 1.1, it seemed that there was like some confliction between whether a pivot was a 1 with zeros above it and below it, or whether it was just like any number where there was only like zeros below it. And you know, so yeah, that I could use a little bit of extra explanation on that.
Sure. So I don't think it's important to define a pivot as a 1 or not. What's important is knowing the difference between reduced row echelon form and just row echelon form, right? And so in fully reduced, it needs to be a 1. But if it's not fully reduced, it doesn't necessarily need to be a 1. And so I'm not going to get hung up on that. That's never going to hurt you on a test or something like that, like if you didn't have the pivot being a 1, unless you were supposed to fully reduce it. I think that was a confusion, was like, does the reduced form have a 1 in the pivot or not? And it really doesn't matter. What matters is you know the difference between the two, and then you know what they tell you. Like, in other words, you fully reduce a system if you want to solve it, for example, right? But you only need to partly reduce it to see if there is a solution. So I think it's a technicality. Probably everyone has their own definition of whether or not it should be a 1, and it's not going to come up on the test, and it really doesn't matter in terms of solving stuff. What's important is that we know how to deal with those types of matrices, if that makes sense. I don't mean to brush that question off, but I don't want to confuse anyone or have anyone get bogged down in some question that doesn't really matter.
You mentioned that all of the like matrices would be reduced. Does that account for the problems where we need to find values of like h and k to make something linearly dependent or make something consistent or inconsistent, or we still have to reduce those ourselves?
Good question. Yeah. So on the test, I am going to ask you to reduce one matrix by hand, and it's going to be one of those HK type questions where like I put in like something like this. This is just an example. I'm just making this up, but like what values of H make the columns linearly independent or something like that. And then it would be like 1, 2, 3, H. And so I'm going to put one of those types of questions on there just to see that you know how to row reduce something by hand. That's going to be like part of the question. And then the other part would be maybe doing linearly independent. I don't know if it's a linearly independent type question, but you know what I mean. One of those types of questions where there's an H in it, you need to row reduce, and you literally have to do it by hand. Outside of that one question, anytime there's a matrix or a system or something, I'm just going to put it at the top of the question, I put it in an augmented matrix, and I just write down the reduced form. That goes for finding inverses. That goes for solving systems. It goes for determining if a linear transformation is 1-to-1 or on 2. I think there's basically 3 times where normally I have people reduce it in their calculator, but instead I just put the reduced version right on the test. And I literally just like have the matrix, the original, and then I just go RREF, and then I have the reduced form, and you just need to know how to handle it. And I didn't put down, I sort of mentioned or alluded to, well, maybe I'd put one on there that like you don't necessarily need or something. I don't think I did anything like that. So if you need to reduce something, it will be reduced, and it shouldn't be, I'm not trying to trick you or anything.
So even for questions where we're like testing if we have like a linearly like independent set of like column vectors, like you just have that reduced too?
Correct. Yeah.
Okay.
Right. So that should be helpful, because normally it's like part of the question is, ooh, they need to know to put it in a matrix and set it equal to 0 and row reduce. And so I'm sort of giving you that part of it and saying, well, you need this information here, and then you just need to know how to use it. So there's, it is in some sense a little bit easier because you don't need to know how to row reduce, or if you're, if you never need to like second guess, like, ooh, do I need to reduce something? Like it'll be there. And so the trade-off is that we're all taking this from home and remote, unideal situations. So I'm trying to find ways to make it more manageable and better. So I'm just looking through the test right now, and it looks like I did that several times.
Yeah, I guess. Oh, sorry.
I have a question about 1.4, where
Sure.
on one of the test topics, it says that how to determine, given a matrix A, what properties a vector B must have such that AX equals B has a solution. Does that just go over stuff like the vector B should be dimensions of AX or A of X once it's transformed, or what exactly would that topic mean for the test?
Yeah, so just looking through 1.4 to be sure it was in that section. So that is specifically referring to the dimensions. And so in 1.4 was talking about how you multiply a matrix times a vector. And so it's like AX equals B. If this one's M by N, this one's N by 1, that means B is M by 1. So that kind of thing. And if you're given an A and an X, you should know whether or not it can produce a B. That's the kind of thing I'm referring to specifically in 1.4.
So are we not going to check through to see if the vector B is in the range of AX, or?
So that is more, that's more from, I mean, yes, but that's just in a different section. That's like a 1.7 topic, I think.
So we'll still have to do that, but not the same section.
Sure, yeah. So 1.4 would be things like A is 2 by 3, B is 3 by 1, B is how big? That's the kind of thing that 1.4 is asking. I think it's 1.7. I'm just trying to page through real quick to remind myself. I think it's 1.7. I'm going to put 1.7 question mark. 1.7 is more like, is B in the range of AX? And that's where you would solve this equation. So like that. But to answer you were specifically asking a question about like what it said for 1.4, and 1.4 is specifically referring to like matching dimensions and knowing how big the result will be.
Yeah, I have just another question. Basically, there was one question on the review, not review, but like topic, which seemed a little vague, and I don't know if the answer is just obvious or there's something I'm missing here. But it said the connection between the solutions to AX equals B and AX equals 0, and my first thought was, okay, well, AX equals 0 is just kind of a form of AX equals B, but B is the 0 vector.
Yep.
And, the homogeneous equation, or the homog, is just kind of what you would solve if you were trying to test, say, if it were independent or linearly independent, while AX equals B is just the matrix form, just the matrix equation. And that's just a very general way of doing
Sure.
things.
No, everything you just said is absolutely true. But this is kind of similar to the question that was just asked. It's like everything you just said is true, and you should kind of know the result of what you just said, but that specific thing that you were asking about wasn't from section 1.5. And in section 1.5, we did this thing where we set, so this is on page 29, you can see it in 1.5. We took a system and we set it equal to 0, and we took a system and we set it equal to 12. The same system, right? And then we looked at the solution and saw how it changed. And the idea was, and there was a homework question from this section too that asked a similar thing. And the idea was you get the exact same solution, right? Like, so the solution line has the same slope, but it's just shifted over because it no longer goes through the origin. And so that's specifically that question, that sort of bullet point was sort of getting at when the solutions to AX equal B will be the same in some sense as AX equals 0, just shifted by B units. Don't worry about, I'm not going to ask a question about that, but that's what that's referring to. It's referring to this specific like situation right here.
Okay.
This kind of thing too, where it's like you have CV plus P, and in the homogeneous equation, P is just 0. And so it just slides it over basically. When you start focusing on questions and you start thinking about these topics, I'm not the kind of person who pulls something, I usually try not to at least, pull something out of left field where it's like, wow, we didn't really see a question like that in the homework. There was never a question like that in the notes. He's expecting us to kind of extrapolate. On tests, I try to mostly see whether, want to see that you understood the material in the notes. So like the questions that are in the notes, the homework questions, excuse me. And I rewrite problems to look similar to them, basically. I don't try to come out of left field is what I'm trying to say. So when you ask that question about this one, we didn't have a specific, I didn't like try to drill this home in homework and things like that. So you might be able to kind of tell like what's important and what's less important, in other words. Maybe the other way to say that is, we just talked about how there are at least 3 homework problems about finding the standard matrix of a linear transformation. Pretty good chance that there's going to be a question like that in a test, right? If I ask that many homework questions, then you can expect to see something like that. So you can kind of get some clues about what I find important, basically, based on quizzes too, right? Whatever I put in quizzes, I obviously think is important enough to quiz on. So I would expect to see like quiz questions on tests and things that I really harp on in the homework. Other things you guys are thinking about? Other specific topics or problems? If not, are there any specific questions about like test format or things like that? We're going to split off into those test groups in just a second here, and I'm going to ask you to submit a fake test or whatever. But before we do that, while we're all together still in this chat, is there things you're wondering that I haven't clarified about? Like, maybe let me just go over it one more time, and then you can tell me if there are questions, and then we'll split up. So I'm going to share my screen one more time because I'm just going to read through this document that I have posted on Blackboard. But this document, which is the instructions for taking remote tests, talks about exactly how this is going to work. Right, so we're all going to split off into our designated chat rooms. I've split the class into 3 different rooms. I have 3 different monitors, and so I'm trying to put like approximately a third of the class on each screen. And you're going to set up your camera just so I can see you. And that's what we're going to practice in a second. We're just going to split off. I'm just going to see that you have a camera that you're able to set up. And then I'm going to ask you to download a fake test. You'll work on the test or the fake test, take as much time as you want. If you have a question when things come up during the test, like it says at the bottom here, you can just give me a call. Here's my number. So my number is right at the bottom. You can have your cell phone. I'm going to be watching you, so please don't like look up answers on your cell phone. But if you want to pick your cell phone up and give me a call because you have a question about a problem, please do that. You'll work through the test following the page breaks. I'll talk about that in a second. And then you'll scan it using the Cam Scanner app and send it back to me as a single PDF. And so I want to practice that today. If you don't have the Cam Scanner app downloaded yet, you should please try to download that right now. Cam Scanner, I'm highlighting it right now. There it is. I will also write it in. Thank you again for Todd for bringing that up. I'm going to write it in the chat here. Well, we got this infinite loop chat thing going. Let me just type this in, Cam Scanner. Okay, here's what the test is going to look like. So this is literally the cover page of the test, actually. And it's got very similar instructions that I just told you. What you're going to do is it's going to be, the test is going to be on the pages to follow, kind of looking like similar to this. And every time there's a new page on the test, I'm going to ask you that you write on a new page on a piece of paper. In other words, the number of pages that you submit should line up with the number of pages that there are questions for on the test. That's going to be extremely important for me grading, because I'm going to read all of these tests into an online thing that'll help me organize the questions and grade them, basically. So I need to have like all your questions on the same number of pages. And so the way I'm trying to get you to do this is by writing these things in boxes. So it says like, write your name on the upper right-hand corner. And then when you get to the end of this page, it'll say, please start a new page. And then at the top of the next page, it says, please start a new page. And then you'll answer questions. And then at the bottom of the page, it says, please start a new page. Or at the end, it says, go ahead and scan up your things and send them to me. And so the test itself, I think, is 8 pages, but one of them's a cover page. And so it's 7 pages, but very spread out. There's some true false questions and things like that. And so you'll scan and send me 7 pages back. This practice test just has 2 practice pages with 3 practice questions that I'm just asking you to download, write on a new piece of paper your answers, scan them, show me you know how to use the Cam Scanner app, and send it back to me. And so in just a second here, when I get us to break, you're going to break off into those separate rooms that I sent out in emails yesterday. If you haven't seen that, you should double check your email. I've sent them out. And then you should, I just want to see what it looks like on my computer. I'm a little bit worried about like feedback and things like that, basically. So I want to see what the setup looks like on my computer. And then I'm going to ask you to submit this test. You'll answer these 2 questions on one page, and then you'll move on to a new page. You'll answer this 1 question, and then you will scan your 2 pages and email it back to me. I just want to see that everyone knows how to do this. I don't want to run into any issues with it on Wednesday, basically, is sort of what we're doing here. If you're not familiar with the Cam Scanner app, let me show you how to use that quick. So I'm going to stop sharing my screen if I can figure that out. And I'm going to switch back over to my document camera and just show you really quickly how the Cam Scanner app works. So it's really great. Again, thanks, Todd. I use this for all my things now. This is how I scan stuff every day. So you like open up the Cam Scanner app, and it'll look something like this. Let me just get to the home screen here. Okay. The button in the middle right here on the bottom looks like a camera, and you would click that button. Although, are there more than one option down there? I can't remember. You want to make sure it's on batch mode. Yeah. So you press the camera mode, and then there's an option on the bottom that says batch. And the batch mode lets you take more than 1 picture. Let me see if I can get this to zoom a little better. There we go. And so let's pretend we had a bunch of, you had your paper down here, your test down there. It lets you take multiple images. So let me go ahead and take multiple images. I'm gonna take 2 pictures of pieces of paper right here. Okay, I just took 3 pictures. And so you can see down here, there's a 3. You click the 3, and then it goes through and it outlines what you scanned. And so you want to make sure it's outlined correctly. If it's not outlined, you can like adjust it a little bit to slide things in. So you can like grab the corner and move the corner in if you wanted to, but you want to make sure your whole page is being selected. And when it looks good to you, you hit the check mark. And what it does is it crops those pages and adjusts the contrast and makes it very nice and easy to read. So I know it's hard to see on this video here, but it takes pencil and makes it look like pen. It focuses things, it crops it, all that kind of stuff. And then when you do that, you can share it. You could share a PDF, you can see, and then you could just share it via email or however you want to do it. You could send it via Gmail or whatever you want to do. Send it to yourself and then forward it to me, forward it directly to me, whatever you want to do. And so that's what we're going to do right now. I'd like you to take a second, close this chat, and open up the one that I sent you yesterday. It should be in your calendar, by the way. It's a calendar right now. Go ahead.
Is the droid cam face cam thing absolutely necessary? And if so, are there any alternatives to droid cam? I mean, I'm sure there are, but like any like reliable ones that people know, because I have failed to try to get that one to work.
Oh, you mean the scanning app?
Not the scanning app, like the webcam app, the one that will allow you to actually see my face.
Oh, so yeah, the reason that do you not have a computer with a camera? Is that the idea? You're trying to use a phone?
Yes.
I guess we can. I don't have a specific suggestion. So have you downloaded the Google Meet app? That's what we're on right now, Google Meet.
I've downloaded. Well, I guess I could use Google Meet directly. I'll try to figure something out.
Okay, it is important to me that I'm able to see you, and so that's one of the reasons why we're trying this right now. So maybe see if you can work that out. Again, if you would go ahead and go to the other link, it should be in your calendar. I thought I put it in the calendar, but now I'm not seeing it. Oh, here it is. Yeah, so if you're not, if you can't find the email, it should be in your Google Calendar. So if you just went to like calendar.google.com, there's a link in there with a Google Hangout meet. And so I'm going to go split off to those various places right now.
Do you guys know where the submission is for this? Thank you.
Okay, I think I unmuted myself for everyone. Let me double check here. Yeah, so I hope you can hear me. So ideally, in an ideal world, it'd be cool if I could like most people have your camera set so I can sort of see what you're doing, which is great. You know, again, I'm just trying to make sure you're not like looking up answers on your phone or whatever. Not a huge deal though. If you're on a laptop or something, I realize it might be hard to like angle it down while also seeing the screen. So that's fine. Just trying this out. At this point, if you would just do that practice test, that'd be great. And so you don't actually print anything. The way that this is going to work and the way that the test is going to work is you should just have the test up on the screen in front of you, but you should just write your answers down on some other piece of paper. There's no need to print. I'm actually prefer you don't print it because there isn't enough room on the actual test to actually write the answer. So it's like you'll have the test up on the screen, you'll write your answers down separately, kind of following the page breaks, and then you will just take pictures of your test when you're done and send it back. And so that's what I'm hoping you'll do right now is just answer those 2 questions on separate, or 3 questions on separate pieces of paper, 2 separate pieces of paper that is, and just show me you're able to scan and send it back. And that's all I'm looking for. And if you have issues, this is why we're doing it right now, so that I can help work out any issues that you might have. So if you have questions about that, let me know. Otherwise, and you can just submit it, just email it back to me is what I'm looking for. Just send me an email with those 2 questions attached as a PDF. And that's it. You can feel free to sign off. If there's any issues, I'll just email you back and say, hey, this didn't work or something. But that's all I'm looking for right now is just a quick dry run of you submitting something. I do see there's some tests coming in. Maybe if you wouldn't mind just letting me verify that yours looks fine, and then I'll just say you're good to go. So I saw my computer is going pretty slow with all these videos. Okay, TJ's looks good. Nick, you're all set. Thank you. Sydney, got it. Let me just mention to Sydney, it looks like yours is kind of cropped weird. So after you take the picture, when you go before you hit the check button, make sure that it's like outlining what you think it should be outlining. So I got your thing in 2 pages, but it's a little bit funky the way it came through. You might want to just double check that and look at it yourself. Let's see here. I got Ryan's email. Let's see how it looks. So Ryan, let me just clarify for you. Let me make sure you're still here. You're here. When you're following the test, like the first 2 questions were on the first page, and then the second question or the third question was on another page. So when you just follow those page breaks, in other words, you should have submitted 2 separate pages scanned as one PDF. I'm sorry?
I did. It just didn't kind of come out that way. But I did have it on 2 different pages. I guess the way I cropped it, it might have been weird. I don't know. They were on 2 different pages with 2 different pictures.
Did you press like, there's a button that's because like tile these or something like that? Did you press that button by chance?
I don't know. It might have been automatically selected, but I didn't press it.
Okay, could you just try that maybe one more time and see if you can get it to come through as 2 pages? That's pretty important from my end because the program I'm using is going to expect you have the right number of pages.
Sure.
Someone else. Let's see. Brendan, got it. Thank you. Looks good. Yours is also cropped a little strange, but it's not bad. It looks pretty good. Thank you. So you're all set. Let's see here. I got Ariana's. That looks good. Thank you very much. You're all set. See here, I'm opening up Jesselyn's. That looks good. Thank you very much. You're all set. I just saw your question, Nick. No, you're supposed to have your name just on the top of the first sheet, just like you did. So that looks good. So you're all set, Nick. I don't know if you're still on here, actually.
So, like, since I'm using my phone as the camera, do you think that, like, because I know what you're trying to prevent is like people using their phone to like look up stuff. So when I'm done, like, because I don't have to use cam scanner. Do I just like leave the call when I'm done, or like?
Yeah, I'll trust you there. And let me also just clarify too. Do you have a computer? Are you going to be able to pull the test up on a computer?
Yeah, I have a computer to like pull the test up on. I just don't have like a webcam.
Okay, that's good. I was just worried about you trying to read the test on your phone. But yeah, that's fine. Just when you're finished, you can just maybe even just give me a wave like, hey, I'm finishing, and then I'll know that that's what's going on. And then you can just scan it and send it in.
All right.
See here. So who else am I waiting for here? See, I think I saw Sydney's already. So Sydney's all set. I saw Roberts. Robert seems good. Charisma's just came in.
I'm working.
Great. Charisma, yours looks good. Thank you. You're all set. I saw Jason's come in. Jason, are you still here somewhere? Yes, I see you're over here on the screen.
We're supposed to email it, right?
Yes, please email. Jason, your scans look good, but they came in on two separate documents. So when you use the app, make sure you choose the batch mode, because that will create one document from all your images rather than two separate images. Can you try to resend that as one document, Jason, if you wouldn't mind? Thank you. And if anyone else is having any issues, I'm happy to try to troubleshoot them with you. James, yours looks good. Thank you very much. You're all set. Adrian, your scan looks good. Just keep in mind that on the test and on these instructions too, you should write your student ID next to your name on the top there. So yours is fine. You're all set. But when on the test day, just put your ID on the top as well. Thank you. Let's see, yours came through again, Ryan. Let me open it up here. Still coming through as one thing.
So do we just submit it on Blackboard?
It's coming through. I mean, I have it. It's one document instead of two.
I sent another one, like two different ones after the first one. I don't know if you
Let's see here. So I just want to be sure you're doing the same process, right? You click the.
So where do we hit it in again?
Just email it to me.
Okay.
You're pressing the button. You take the pictures, and then you're just hitting share, right?
Yep.
Okay. Oh, it's not. It's coming through as one thing. It's not a huge deal if there's. Oh, it did come through as two. The second one came through as two. The second page just took a while to load for some reason.
Okay.
And also see you're having a hard time. What can I do to help with that? Do you think you have more work in this? Do you think there's more work in this class than there was before?
No, not in this class in particular. I mean, maybe a little bit, but not in this class in particular, just in general.
Yeah, I did try to avoid that because I know it's kind of like it's almost like a double assignment where you have to do something before and then we meet. But I'm trying to keep these meetings generally shorter, and then the videos I'm trying to keep less than an hour. I know it's hard at times, but anyway, I know it's tough. Are you working too? You still working?
Yeah, I'm working, and like I live in Vermont, so there's just a lot of stuff to do, like for your house when you live in Vermont, just to make sure like you don't flood every day or whatever.
Sure. No, I understand. There's a lot going on. So let me know if you want some help with anything, and I hope you're taking advantage of some of those pass-fail options.
Yeah, no, I'm all set. Thank you very much, though.
All right, you're all set. Thanks, Ryan.
Bye.
Bye. What was that, Finton?
Did you get mine, and can you read mine?
I just got it, and it looks good. Thank you. It looks great. All set.
Can you read it though?
I can. Do you want me to?
Okay.
You want me to read out loud? You mean, or I can read it?
No. I just wanted to make sure because the last thing I would want is to have my stuff be illegible.
Nope. Yeah, that's the wonderful thing about this app is even really light handwriting and stuff. It makes it very visible, so it looks great. Yeah.
Okay.
All right. Thanks. I just
So,
received
am I free to
Aaron's.
leave?
Let me open up Aaron's here.
So am I free to leave?
You're all set. Yep.
All right. Thank you.
Aaron, I got yours too. Just let me just make one comment. It should have only been 2 pages. So when you do the test, and these were the instructions on this test as well. It said just put your name and student ID at the top of the top page. So not like on its own page, just on the top of the first page. Not a huge deal, but just when you do the test, just start your problems, but put your name and stuff on the same page. Otherwise, all set. Thank you. See here, I'm opening up Alex's right now. Alex looks great. Thank you very much. Although it doesn't look like you use the app, and I can tell because it's kind of hard to read. Are you just taking a picture with your camera? Let's see where Alex went.
I used Chem Scanner.
Did you? I don't see the watermark, and it definitely doesn't look like a cam scanner thing. Maybe it's fine. I can read it okay. I just maybe thought it wasn't. I'll take your word for it, though. Otherwise, it looks fine.
Okay.
Thank you.
Yep.
Let's see. I'm opening Todd's now. Todd looks good. Thank you. Opening up Kaio. Did I say that right?
Mhm.
Looks good. Awesome. Thank you.
All right, thanks a lot.
Opening up Zach's. Zach looks good. Thank you very much. Although, let's see here. Did you answer these questions? I can't remember what my questions were. I only see 2 questions. 1, how old are you? 25. 2 says the PDF part. No question 3. So let me just clarify. Like there were 2 questions on the first page, so there should have been 2 questions, and then there should have been a single question on the third page. And I just want to clarify that because that's important when it comes to the test. I'd like to see those in the correct form. Otherwise, looks fine. If you have any questions about what I just said, let me know. Robert, yeah, yours came through a while ago. I don't know if you're still around or not. You're still here? I think you left. Let's see. I see Williams. Let me open up Williams. Only seeing 1 page on Williams. Yeah, there's only 1 page on this one, Williams. Okay, I see your response, Zach. Okay, you're all set then, Zach. Thank you. Jason, did you resend? I see what you said, William. Just give me 1 second. Let me know if you need any help, Jason or Joseph. So William, when you scan it and when you go to share, you need to be on the screen that shows all 3 pages. If you're on like one of the specific screens, it'll just send that one page. So it needs to be on like the page that has all of them. Let me double check again for yours, Jason. Okay, yours looks good. I got it, Jason. Thank you. Joseph, I just got yours. Let me open it up here. Looks good. Looks good, Joseph. Thank you. Let me know if you want to pop back on, and I can go on the doc cam and show you again if you want. So, can you see my screen? I know I've got my thing off. Let me turn it. Oh, I'm on the wrong thing. Let me try this. So, okay. Not yet. Oh, here it came through. Let me see. Okay, that looks great. Thank you. I appreciate it, William. Take care. it.